Hello everyone, my name is Elijah Proctor, and today we're going to be talking about how you might choose to use ANOVA over linear regression or linear regression over ANOVA in certain situations. And so we're going to be using a real life data set, which is our NBA games data set. And this has what we're mainly going to be focusing on is the minutes played and the points scored for different players on different games for different teams. And so what we're doing here is we're trying to determine when to use ANOVA versus linear regression using this data set. And so here ANOVA is used to compare the average points by players from different teams. So we have our Milwaukee Bucks, San Antonio Spurs, and our New Orleans Pelicans, and we're trying to see if there's a significant difference between them. So we have linear regression on the other hand, and we're going to be using this to examine the relationship between the number of minutes a player plays and how many points that they score. And so let's go through the code really quickly. So first we need to load the data set from the CSV, and then we're going to narrow down our data to only include the teams that we had specified, so Milwaukee, San Antonio, and New Orleans. And then we're going to filter the data based on the teams we're trying to target. Then we're going to conduct an ANOVA test. So we have our points, which is our independent variable, and our teams, which is our dependent variables. And then we're going to basically call this ordinary least squared function and make sure that it's fitted. And then once we do that, we can put these ANOVA results into our ANOVA function, and then this gives us our summary. So then we just print out what our ANOVA summary is. And then so in order to visualize the point distribution across the selected teams, we're going to basically just pass the data, filter data in as a box plot. And we have our X, which is our team name, and then Y is our points. And then now for our linear regression test. So first thing we're going to do is we're going to apply the conversion to our minutes column. And so this has the minutes that the player had played in the game. And so in order to make sure that this works with our linear regression test, we have to convert the time, which is a string, into a float value. And then we have to make sure we remove any rows that are invalid. And then once we do that, we should be prepared for our linear regression test. So for our X, we're going to have this set to our minutes, and then here we have our Y is going to be our points scored, and we're going to create a constant to the independent variables for our regression. And so we're going to call this add constant and then pass the minutes into this function. Then we're going to fit the regression model to the data. So we're going to call our ordinary least squared with our minutes and our points passed through. Make sure that it's fitted. We're going to print the regression results, calling our line regression results.summary. Then after that, we're going to plot the linear regression line. So we have our linear regression line, which shows our regression between our minutes versus our points. So now let's go through the results that we had gathered. So our ANOVA test was performed to see if there are significant differences in the points scored among players from these three different teams. Our F value is 0.18 and our P value is 0.836. And so since the P value is a lot greater than 0.05, this means that there isn't a statistical significant difference in the points scored by players from these three different teams. Our box plot here shows the distribution of points scored by players from the three different teams. Our median and spread of the points are similar across all the teams. There are some outliers visible, and this supports the ANOVA results that we had, which showed that there's no significant difference in scoring between these two teams, or these three teams. Now let's look at our linear regression results. So we have a linear regression performed to analyze the relationships between the minutes played and the points scored. Our R-squared value is 0.501, meaning there's about 50% of the variance in points scored can be explained by the minutes that are played. The coefficient for minutes played is 0.6187, which means that for every additional minute played, a player is expected to score about 0.62 more points on average. Our p-value for the min is very small, which indicates that this relationship is statistically significant. So lastly, let's go over our scatter plot with the regression line. And so this shows the relationship between minutes and points scored. Our red regression line shows our trend, and it has a positive slope, which confirms that as the players spend more time on the court, they tend to score more points, which is consistent with the linear regression results that we had just analyzed. So yeah, so this is an example of when you would choose ANOVA over linear regression and vice versa. Thank you guys for listening. You all have a nice day.